Um, got it. Okay. I'm very happy to be here. I'm very much enjoying my time on your beautiful island and getting a lot of productive research writing done here in this gorgeous space. And so I'm happy to be able to talk to you about one of the things I find fascinating, which is the role of sleep in our lives. Something maybe we don't think a whole lot about. So I'm just going to jump in. Before I get going, I wanted to show you where I'm from. So here's a map of South Carolina, North Carolina up here, Georgia down here, and up in that northwest corner is a city called Spartanburg, and that's where I teach at Wofford College. It's our main building on the college. We are only undergraduate students, about close to 2,000 of them right now. And our mission is focusing on liberal arts education for undergraduates. And we do have active research labs there, and it's a very engaging place. So if you're ever in South Carolina, I'd love for you to come visit. All right, so I wanted to start just for your own use. We're not going to share this with each other, but just write down how many hours of sleep did you have last night, or jot that down. And when you do that, if you could think about the quality of that sleep and rate it from a 0 to 10. So, think about how long it took to get to sleep, if you were restless, if you woke up during the sleep, things like that. All right. And then if it wasn't a 10, when was the last time you remember getting that really great night of sleep and waking up totally refreshed? Right. So can you remember when and where that was, and what might have been different about that time and place compared to, say, last night? Right. And so my goal today is hopefully to teach you something about slow wave sleep and REM sleep, and what it does in our brain and some of the important functions that it has, but also hopefully to take away a better appreciation of the need for sleep. I like to say that sleep should be non-negotiable, and we tend to make it negotiable. When other things come up in our life, sleep is usually what gets pushed aside. And so we'll talk about why maybe that's important to focus on not doing that. All right, so we spend a third of our lives asleep. That's pretty amazing that, a third of our lives we're sort of unconscious to the world. And so why do we do that? And there's two theories about this. One is a repair and restoration theory, and we will certainly show some good evidence of that and why we need sleep for our body to sort of rebuild its resources. And an evolutionary theory of sleep, meaning that when at, say, nighttime, when it's not as efficient to be active, it's better for us just to sort of conserve energy. And we see that across lots of different species. So all species of animals, especially mammals, sleep. Some, like a bat over here, sleeping 20 hours a day. It only really needs to be active at dusk and dawn, when it can go out and have a wealth of food, insects to feed on. And other than that, it makes sense for that bat to be somewhere very protected and sleeping and not using up energy. And then we have on the other end big animals like horses and goats and cows that have to graze, have to eat a lot of vegetation to get their energy. And so they spend most of their day eating, and they're pretty vulnerable to predators. And so it doesn't make sense for them to be unconscious for a third of the day. So they only sleep about 4 hours, but they still need sleep. So that, repair restoration theory is definitely part of this. I'm going to show you this quick video clip, and I just have the sound up on my computer, but this is a clip of Felix Baumgartner, who is attempting to set a world record for the highest free fall. So he's in that little space capsule looking thing, and he's attached to this balloon. And this is being filmed and recorded by Guinness World Records. Obviously they have some sponsors there that are part of this, but he's going to go up to 24 miles above the Earth, to the very edge of our atmosphere. And we'll just watch here as he opens the hatch. It's probably not something most people would do voluntarily, right? To go up that high, almost in outer space, and then jump. Very good. So he's going to fall now 24 miles up to a speed of almost 850 miles an hour, break the speed of sound barrier. And you see his parachute come out. There we go. And everybody's very excited because he's broken all these records. He actually broke 8 world records in that attempt and was inducted into the Hall of Fame by Guinness World Book Records. So you might be wondering, Dave, what does this have to do with sleep? This has nothing to do with sleep. Well, actually, as dangerous as that looks, Guinness World Book of Records has banned people from trying to break a sleep deprivation record. They have deemed sleep deprivation so dangerous that they will not accept any challenges or offers to record that. So, you know, they will support something as crazy as jumping 24 miles out of a balloon, but not sleep deprivation. So sleep deprivation is pretty dangerous, right? If we talk about like the importance of sleep, if you think about how many days could you go without food, and I know on Zoom it's hard to have a conversation, but maybe get a number in your head about how many days you could go without food. And I'll tell you, the world record for that is 74 days. Most people can go about a month. It wouldn't be pleasant, but we carry around a lot of calories in our body, and we can last about a month. And what about water? Do you think more or less time that you can go without water than compared to food? And most people get that right, that it's less days. In fact, 18 days is the record. Most people can only survive about 3 to 4 days without water. And you know, we don't carry as much of that around with us. Now, let's talk about sleep. What do you think the record is for sleep deprivation? It is 11 days. That's the longest any human has ever gone. Most people cannot function after 2 days of sleep deprivation. You and I would have a very hard time functioning with that. So it's very important that we get a consistent and a big continuous block of sleep every night, somewhere between 7 to 9 hours. 8 hours sort of in that average, right? You know, naps can help remove some of the sleep pressure during the day. I'll talk about sleep pressure in a minute. But they really don't count towards that 7 to 9 hours. You need to have a block of 7 to 9 hours, and we'll talk about why that's important. All right, so when you get inadequate sleep, it really initially affects our concentration. And it does so in a way by having us go through these micro sleep periods. It's a momentary, less than 2 seconds, sometimes even less than a second, lapse in concentration, and we're often not even aware that we're doing it. We don't even know that it's happening. And the reason we care about this is every hour somebody dies in a traffic accident that's related to fatigue. And so if you have one of these micro sleep events and you're traveling at 30 miles an hour, you've gone about 30 yards without paying attention to what's going on. And obviously as the speed goes up, we were traveling much greater distances. So understanding this is pretty important. Researchers did an experiment where a light would flash for like half a second. They had a 10-minute trial, and the subjects simply had to push a button every time the light flashed. And they measured their reaction time, how long it took to push the button, and they measured their accuracy. Did they push the button every time the light flashed? And not surprisingly, sleep deprivation increases reaction times, right? If you're drowsy or slower to do things. But what might be surprising is that one night of sleep deprivation caused 400% more misses, meaning the people just didn't see the light. The light flashed, but they were in one of those micro sleep moments, and they missed pushing the button. If they had 2 nights of sleep deprivation, it went up 8 times, 3 nights, 12 times. So pretty serious. Now you might be saying, sure, I've not gotten sleep in a night and I'm miserable the next day. That makes a lot of sense. It's not just a full night's sleep. So if you have 4 hours of sleep for just 6 nights, it causes the same number of missed responses as a single night of sleep deprivation. And if you extend that from 6 nights to 11 nights, it's the same as having 2 nights of sleep deprivation, these micro sleep events that are happening. And it's not just very brief periods. The researchers also looked at, well, what if we give you 6 hours? 6 hours is pretty close to 8 hours. 6 hours of sleep for 10 nights, consecutive nights, cause the same number of misses in this simple test as 1 night of sleep deprivation. So when we say 7 to 9 hours, that's 7 hours is a pretty firm barrier to not have problems with concentration the next day. Last thing I'll talk about before we get into sort of some of the mechanics of sleep and what it's doing in our brain is another experimenter compared a driving simulator and counted the number of times that they went off the road. They have 4 different groups, a control group that was 8 hours of sleep, a 4-hour sleep group. Then they had the control group, but they were legally impaired, they were legally drunk, and the 4-hour group. And not surprisingly, 4 hours of sleep sober had 6 times more off-road events compared to the 8-hour sleep control. And it was equivalent. It had the same number of off-road events as if you had slept 8 hours, but were legally impaired, were drunk. So sleep, inadequate sleep can really affect our ability, particularly in a complex task like driving a car. And obviously, if you have 4 hours of sleep and you're legally drunk, it's exponentially worse, right? And so, that's a very dangerous combination of being impaired and having lack of sleep. So some take-home points. How long awake is too long to be awake before we need sleep? And it turns out that you start having these problems with concentration after about 16 hours of being awake. That means if you got up at 6 a.m. this morning, around 10 o'clock tonight, you're not going to be operating at optimal levels. Your concentration will begin to be impaired. You'll start to maybe have some of those micro sleep and things. The good news is that getting those 8 hours of quality sleep is enough to sort of wipe the slate clean and start over fresh the next day. And you just need one of those extended periods to sort of wipe that slate clean. So what does wipe that slate clean mean? We have 2 processes that sort of underlie our sleep-wake cycle. One is this circadian rhythm that we're most awake and alert during the day, and then our circadian cycle starts to make us sleepy at night, and this just goes up and down, back and forth. And that's an internal clock thing that we have going on in our hypothalamus in the brain, just regulates ebbs and flows. The second process is this sleep pressure that happens. And there's a chemical in our brain, in the hypothalamus, in the sleep-wake area called adenosine. And the longer we're awake, the more adenosine builds up. It's the result of brain activity. And so the longer our brain's active, the more this builds up. And it increases the sleep pressure until we get to a point where we have high adenosine, low circadian rhythms, and we have this strong urge to go to sleep. Right? 7 hours of sleep is enough to fully eliminate that adenosine out of our brain and start over fresh at 0% the next morning. Right? And that's the ideal situation. Now, when somebody doesn't sleep, has sleep deprivation, that adenosine just keeps building and building. Our circadian rhythm kind of chugs along down here, but the adenosine keeps building and building until at some point we can no longer stay awake. The sleep pressure gets so great. And what's interesting is when you have that situation like we just talked about, where you only get 4 hours of sleep, right? You don't fully eliminate that adenosine. So when you start the next day, you're not at 0. You already have adenosine in there. And so it begins to stack up. So when you have repeated days or nights of sleep less than 7 hours, you're not wiping the slate clean, and you start to build up adenosine and makes us drowsier during the day. People often want to know about, well, what about caffeine in sleep? Well, caffeine has a role in this. It blocks adenosine. It's an antagonist for adenosine. And so when it blocks it, it helps reduce that sleep pressure, but it doesn't get rid of the adenosine. So as the caffeine drug wears off, the adenosine pressure is still there, still very high. We have to sleep in order to wipe that slate clean. All right, so I want to just sort of go over some basics about the stages of sleep, because there are 2 really important stages of sleep. And these are categorized or identified based on the electrical activity in our brain. So here we see when we're awake, we have this sort of asynchronous electrical activity called alpha and beta rhythms. And that is just our brain doing its cognitive, conscious, perceptual stuff that it does when we're awake and paying attention and doing tasks. Right? Then we have two sort of transitionary stages of sleep, stage 1 and stage 2. Maybe less interesting. There's some things in there like these big spikes of brain activity that we think are helping shut down our brain, sorry, and help us reach stage 3 and 4, which is what we call slow wave sleep. See that down here in the pink and purple. We have these big delta rhythms that are synchronous activity in the brain. So while awake and behaving behavior is very asynchronous, lots of things firing at once, these are big groups of neurons firing together, and it's almost like a ripple across your brain. We used to think that wasn't really doing anything, but now we know that actually is doing a lot, that electrical activity is really important. I'll talk about that in a second. And then finally, we have our 5th stage, which is not called a stage, it's called REM, or paradoxical sleep. And in this case, the brain, even though we're asleep and not conscious, is exhibiting awake-like activity, these beta rhythms. So it's firing here, and that's also doing some really important things. And this is when we experience dreams. So when we have sort of a conscious awareness of this awake-like activity, our brain tries to make sense of it and creates this dream that sometimes we remember. All right, so these stages are cyclic. They happen about 5 times in a normal 8-hour period. They're about 90 minutes each, but they're not the same in the beginning and the early part of the night. And that becomes really critical. Is one of the reasons that we need to get that continuous 8-hour block, so we can get both the beginning and the end of the night portions of that. So in the beginning of the night, most of our slow wave sleep is happening. The periods of slow wave sleep are longer, and they're primarily focused in those first 4 hours. We do come up for short periods of REM sleep early in the night. It does cycle. It's not like continuous slow wave sleep, but most of our REM sleep durations are happening in the second 4 hours of that sleep. So often when people wake up in a dream, it's usually in the morning, not in the middle of the night, because of the way our normal sleep progression happens. All right. So if, for instance, your brain is really good at trying to predict what you're going to do. And so if normally this is what it wants, 8 hours of sleep, and you have an alarm that goes off after 4 hours of sleep because you have to catch the early plane off the island or whatever it is that you have to do, then your brain is going to realize the next day, hey, I only got the slow wave sleep. I really didn't get that REM sleep that I needed. And so the next night, it's going to predict you're only going to give it 4 hours, and it will try to compress all of those stages into the first 4 hours. And so you end up with not just one bad night of sleep, but then the follow-up night, even if you sleep 8 hours, your brain is off circuit. It's trying to do things in a shorter period of time. And so that's why being consistent, like having the same amount of sleep every night, is really crucial. So your brain can predict and rely on that. Okay, so let's get down to the purpose of this. And I'll talk first about slow wave sleep, because we've known a little bit about REM sleep for quite a while. This slow wave sleep stuff is relatively new. In the last 10 years, we've started learning, hey, there's some important things. The brain used to be thought the brain was just kind of turned off in slow wave sleep. That's definitely not the case. So early in the sleep cycle, we have 2 primary tasks that we know of so far with slow wave sleep. One is that restorative sleep that I talked about at the very beginning of the talk. So during this time, you're having a big release of growth hormone that's helping repair things in your body. Your immune system gets very active and makes a whole bunch of white blood cells to sort of replenish your immune system for the next day. And your brain actually opens up and allows metabolites and toxins and things that have built up from the previous day to sort of clear out, and there's sort of a cleansing of the brain. There's also a very important role for declarative memories. And so some of this research is based on studies where people were in sleep labs and they selectively deprived them just of slow wave sleep and looked at, okay, what are the deficits they have in the next day? And from that, we can tell that in slow wave sleep, the brain is sort of sorting through the previous day's memories and filtering, okay, this is important. I want to consolidate this and remember this. And this is not so important, and I don't really care if I remember that. So we talk about declarative memories. We're talking about facts, information, things that we want to remember past that day, as opposed to episodic memory, which is sort of remembering what happened during that day. So as I mentioned, here's some of the research, and I will, throughout this talk, I'll provide these slides to Dr. Hamilton after when we're done, and they do have links to the various references and research on here if you want to read more about it. But during slow wave sleep, we can measure this in mice because they allow us to put these fluorescent chemicals in their brain, and we can actually measure this stuff. We assume the same thing's happening in humans. But during slow wave sleep, the space in between the cells in your brain opens up about 60% more than when you're not in slow wave sleep. And we think this is that cleansing. It's the ability of things in that fluid, that's cerebral spinal fluid, to sort of clear out of the brain and sort of wash the brain, if you will. Also, as I mentioned, the declarative memory. So what is a declarative memory in your brain? It's simply a bunch of neurons that have gotten stronger together and formed this network that represents a piece of information. And the more times that group of neurons fires together, the stronger the wire becomes, right? So when you're trying to memorize information, what do? We rehearse it, right? We stimulate that circuit over and over and over again, so that when you have a test and you have a retrieval cue, it's going to activate that whole circuit, right? And this is what we think is happening during slow wave sleep. So when we have these big synchronous patterns of activity, it's sort of rolling from the front of our brain to the back of our brain. And what that activity is, we think, are groups of neurons that are all firing at the same time and strengthening their connections. And so this is, we think, solidifying connections that were made, memories that were formed the previous day. And more importantly, research has shown that if we don't get slow wave sleep, what we learned yesterday interferes with what we are going to try and learn tomorrow. So one of the things slow wave sleep does is, besides strengthening connections, is sort of wiping the slate clear, so the next day we don't have interference from the stuff we learned today. So we can sort of start fresh with that. All right, so what about REM sleep? REM sleep is sleep that happens mostly late in the sleep cycle, and there's at least 3 things that we know REM sleep's doing that's different than slow wave sleep. While declarative memories are getting strengthened in slow wave sleep, procedural memories, how to do stuff, is getting cemented in REM sleep. And I'll show you some research that supports this kind of learning, right? So if you are learning to play an instrument and you practice it during that day, that night, your REM sleep is solidifying the connections that were stimulated by doing that practice. It also is not a mistake that REM sleep happens after slow wave sleep. So those declarative memories in slow wave sleep that got sort of solidified, REM sleep kind of organizes and cleans those memories. It connects those memories to old memories, says, okay, these things belong with this other group of neural networks. And we have some pretty good evidence that I'll show you that it is removing some of the emotion from those memories, right? So I'll give you an example of this. Last summer, my dog passed away, and it was part of our family. You know, we had a lot of grief associated with that in the immediate aftermath of that. And now I can think back and I have those same memories of the day that our dog passed away and all the things we did, but it doesn't evoke the same negative memories that it did immediately after that event. And we think over time, REM sleep is the thing that's sort of removing that negative emotion. And then finally, and this is a very important one, REM sleep appears to strengthen the ability of our prefrontal cortex, the very front part of our brain, to control a lot of more primitive cognitions like emotion, reward, impulsivity. So the prefrontal cortex is sort of like the brakes on all of that stuff. And again, selectively depriving people of REM sleep, I'll show you some research on this, removes those brakes and weakens the ability of the prefrontal cortex to sort of govern that. And then, as I mentioned before, dreams are sort of perception when we remember this awake-like REM activity that's happening, right? So two very different types of brain activity. Big slow waves that are stabilizing connections, and REM sleep that is more like awake brain activity, doing different things. All right, so let's pull this up here. What do we know about REM sleep? And there's a lot we don't know. I mean, we're really just sort of scratching the surface of understanding sleep. But what we do, some of the things we do know is that transitioning out of slow wave sleep to REM sleep involves stimulation by this area of the brainstem called the pons that sends signals up to this area of the thalamus called the geniculate nucleus that is then connected to the occipital cortex. And from there, this awake-like activity spreads from the back of the brain towards the front of the brain. Right? And it's going to activate motor cortex. So if you ever remember a dream, that perception, often you'll be moving or running, or there'll be motor sensations associated with that. And there's a special part of our brainstem that inhibits the descending motor signals so that we don't run in our sleep, or we don't do these muscle movements when we're asleep. Now, REM sleep does anyone know what the REM stands for? I've just been saying REM, but it stands for rapid eye movements. And it turns out the motor control of our face and our eyes is through cranial nerves that are above that level of the brainstem where the paralysis is happening, which is why we still get the motor movements of eyes and the face during REM sleep. So REM sleep, we know, is very crucial. If you deprive humans of REM sleep, this initiation of these patterns of activity can happen even when people are awake. When it gets to the extreme, the brain just sort of shuts off, even though you're trying to keep them awake, and initiates REM sleep. So we know it's very, very crucial process, very critical process and necessary. Some of the other things we know a little bit about the neurochemistry that's happening during REM sleep. So throughout the day, we have norepinephrine. NE stands for norepinephrine, which is a neurotransmitter that's released in response to meaningful events and emotional events. It's what helps us stay vigilant and helps us store information. And interestingly enough, the only time that our brain doesn't have significant levels of norepinephrine is during REM sleep. So there's essentially zero norepinephrine during REM sleep. And that's going to become very important in the cleaning of emotion off of those memories. And I'll talk about that. If we have norepinephrine present and we're stimulating these emotional memories, then it's not going to be able to remove that emotional component. Another neurotransmitter that we know is involved with sleep is serotonin. And serotonin levels are very high when we're drowsy. And as we are in those early stages of sleep, they start to decline and are essentially zero during REM sleep. But interestingly, right after we come out of REM sleep and go into that cycle of slow wave sleep again, there's a big spike of serotonin throughout our brain. So we think that that is a way to sort of flip the switch from this awake-like REM activity back into the delta waves, the slow wave sleep. That serotonin is the neurotransmitter that's sort of flipping that switch between these two very different states of brain activity while we're asleep. Another thing we know about REM sleep is that it is not constant across the lifespan. Infants and children have a large amount of REM sleep. And so, the first role I said that REM sleep had is to help us learn how to do stuff. And infants and children are learning how to do a lot of stuff like crawl and walk and talk and interact with other human beings and display correct emotions in response to things. And so we think that they need a lot more REM sleep because of the amount of procedural learning that they are doing in childhood. And after about age 10, that sort of proportion of REM to slow wave sleep stabilizes and remains pretty much the same throughout the rest of our lifespan. So after about 10 years of age, REM sleep is less of the total amount of sleep, and slow wave sleep is more, as you can see. But about a third of our 24 hours we should be spending in REM and slow wave sleep. So as I mentioned before, if you selectively deprive humans of REM sleep, they will go into REM sleep sooner in their sleep cycle, more often, and they won't get the same quality of sleep. So they'll feel more restless and tired, probably because that REM sleep being earlier in the night is interfering with the restorative processes of slow wave sleep, which is again why it's really important that we get both, that we have both the early and the late night patterns. Experiments have been done with learning how to do stuff with rats. So in this particular experiment, both of these rats were trained in a maze. And then that night, when they were going to sleep, this rat on this side, on the left, had its brain waves analyzed. And anytime that rat went into REM sleep, this little turntable started moving and knocked it into the water and woke it up, right? So we can selectively deprive this rat of REM sleep, right? The other side of that turntable has another rat who's also going to get woken up the same amount of times. The poor rat's going to get knocked off of his turntable, but it's just not going to correspond directly with his REM sleep. So sure, some of his REM sleep is probably affected, but we know that this animal gets 0 and this animal gets some. And it turns out the next day, the animals that got 0 REM sleep do a whole lot worse in that maze. It's as if they haven't learned what they were supposed to the day before, compared to those animals that got woken up the same amount of time, but we didn't directly interfere with their REM sleep. Another way we can look at that is not to interfere with REM sleep, but just to measure it. And so in this experiment, the orange line is the rat's performance in a maze, and you see that as they're learning it, it's going up just a little bit. And the blue line is the amount of time that rat's spending in REM sleep each night. And what's interesting is often when you're training animals in these types of tasks, there becomes a moment where the animal just figures it out, and then it can do, its performance goes way up and it's able to do the task. And that's what happens here. But what's interesting is the 2 nights before, so here's where the animal figures out how to do the task. The 2 nights before, when it's still kind of struggling along, there's big increases in REM sleep that's happening. And then once it learns how to do that task and can do it very well, the REM sleep goes back down. So just before the animal shows us that it learned how to do the thing, its REM sleep goes way up. So again, some pretty good evidence that REM sleep is involved with learning how to do stuff, procedural memories. One of the other important parts that I mentioned of REM sleep is strengthening of that prefrontal cortex, the ability to govern things like the amygdala. So when we talk about the prefrontal cortex, I like to refer to it kind of as the brakes in the brain. It sort of makes sure everybody isn't speeding and doing inappropriate things in the brain. It's sort of maintaining control. And the amygdala is sort of like a gas pedal, right? And so this is the emotional center, our primitive emotional center in the brain. And when this is like a seesaw. So when prefrontal cortex activity is low, which is what we're showing here on this side in D, when this side is low, then we have very high amygdala activity. The seesaw moves. And so the amygdala goes unchecked. It's not governed by the brakes, and vice versa. If we, have it go the other direction, then we may not get appropriate emotional responses. That typically isn't the case, though. So again, study looked at depriving humans of REM sleep, just REM, no other type of sleep. And what they found is it leads to a lack of emotional self-control. And it's like the brakes here in green become uncoupled to the amygdala, and the amygdala gets a lot more active. In fact, the amygdala gets about 60% more active following one night sleep deprivation. And we see that over here. We see these are just two different measurements of amygdala activity, and the no sleep group has a lot more of that. What's interesting is it doesn't have to be a complete sleep deprivation. In fact, they did this study, again, looking at 5 hours of sleep for 5 nights, so not getting that optimal amount of sleep. And they saw the same sorts of effects where the amygdala becomes unchecked, and we have this lack of emotional self-control. The prefrontal cortex also controls roles of impulsivity and reward. And again, sleep deprivation studies show a loss of rational control of impulses, so increase in impulsive behavior, and a hyperactivity to rewarding experiences. So again, prefrontal cortex, very important to sort of control some of these primitive emotional areas of the brain in rational decision making. And we'll sort of come back to that at the end when we talk about the role of sleep and mental health as well. So going back to those low levels or 0 levels of norepinephrine during REM sleep, and that is the norepinephrine is that vigilance alertness signal. What we think is happening during REM sleep is part of that awake-like activity is activating emotion-specific memory areas of the brain. It's sort of reliving that emotional memory, the memory that I have of when my dog passed away, for instance, except there's no norepinephrine present. So we can activate this upsetting memory in a safe neurochemical environment so that it becomes less upsetting. It's the norepinephrine that encodes the emotion part of that. And by not having it, we're like, okay, that doesn't have to be as sad or as negative an experience. It sort of helps remove the emotional edge off of previous events. One of the interesting things is that in therapy, when people are being treated for things like major depressive disorder, some people respond better to the therapy than others. And a study looked at these sort of responders to therapy and non-responders and measured their REM sleep. And it turns out it can help explain differences in improvement during therapy based on the amount of REM sleep. The ones that were getting the most benefit from the therapy were showing the greatest amounts of REM sleep. The ones that were not getting as much improvement of negative emotions tended to be on the smaller side of the spectrum for REM sleep. So that's kind of anecdotal data. There's also been experiments that have tried to control for this and really look at it. So in this study, 2 groups of people. One group at 8:30 at night was shown a bunch of images. Some of them were benign images, some of them were very emotionally disturbing images, and they rated how emotional those images were from 1 to 5, 1 being not emotional, 5 being very emotional. Another group did the same thing, but at 8:30 in the morning. They went, one group then slept all night, and at 8:30 in the morning, they retested on those same images to see how emotional they were. And the other group was awake the whole time, and they retested. And it turns out that the sleep group, this is a percent change in their emotional ratings, had a very negative change in the most graphic images. So they rated those 4s and 5s that are the most graphic emotionally as much less emotional after they slept. Did not see the same thing happen for the people that were maintained being awake. And they did fMRIs of these individuals. And it turns out that the sleep group had a decrease in their amygdala's response to those emotional activities and an increase in their prefrontal cortex. So the ones that were able to sleep had stronger governance of that. And the ones that were just awake the whole time didn't get the benefit of sleep to strengthen the prefrontal cortex and had higher amygdala activity, right? Also very interesting, there's variance in these studies, and some people showed greater gains than others. They looked at the amount of REM sleep, and the people that got the most REM sleep in that sleep group showed the biggest changes in their amygdala activity and the biggest changes in their emotional response. So individual differences corresponded to this. It's really interesting. So we learn about this and we want to make clinical applications of it. And with PTSD patients, some patients are non-responders to therapy, and they have a very hard time with flashbacks and very high emotional activation. And they often show disrupted REM sleep and higher norepinephrine levels than patients that are able to respond positively to PTSD therapy. Often these patients also have nightmares associated with their PTSD. And so what we think is happening is that in the night, REM sleep is trying to do its thing. It's trying to strip the emotional component away from that traumatic event, but norepinephrine is present. So it's essentially reinforcing the traumatic event instead of removing the emotional component. And so it tries the next night and the next night and the next night, and that's why they get these reoccurring nightmares. And so several studies have used a drug called prazosin that suppresses norepinephrine levels during sleep. And those patients that received this over a 2-week period showed a reduction in nightmares. So REM sleep, by removing norepinephrine, REM sleep was able to do what it had been trying to do. And they showed improvements in the PTSD symptoms. This is a relatively new idea in treating PTSD. And it's mostly case study data. There's only been 5 randomized trials that I've been able to find. But all of that data really supports, even the randomized clinical trials, supports this idea that if we allow REM sleep to do what it's supposed to do in absence of norepinephrine, it can help reduce the emotional component of even traumatizing memories. All right, so that sort of brings us to mental health and sleep, and the last sorts of things that I want to talk about in the last couple slides I have here. There is no major psychiatric condition in which we see normal sleep patterns across the spectrum. And the prevailing view has been, well, these mental disorders are interrupting or interfering with sleep. And that's probably not as nuanced a view as we need to have. It's probably a very bidirectional relationship where mental illness can disrupt sleep, but when we have disrupted sleep, things like REM sleep can't do some of the things it needs to do. People aren't able to concentrate as well. They don't get the restorative properties of sleep. And so disruptions in sleep can actually then contribute to the severity maybe of that mental illness. Not to say that it causes a mental illness, but it definitely can interfere with therapy or the ability to treat it. Some examples of this are people that have obstructive sleep apnea. So this is where they interrupt their normal quality sleep schedule because they're waking up, they're having this apnea, this hard time breathing during sleep. And those patients tend to have much higher rates of mood disorders, anxiety, PTSD, psychotic disorders. And a study looked at if you could successfully remove the sleep apnea through CPAP therapy, that at 1-year follow-up, those patients had improvements in their depressive symptoms, presumably because we've allowed them to then now have quality sleep and not interrupt those sleep processes, right? So, the clinical implications of this as clinicians or future clinicians or counselors is that promoting proper sleep hygiene and health is a real potential therapeutic technique. And it's something that has no side effects, it's free, and it's totally under the control of your client or your patient, right? So just getting the word out and making people aware of what sleep patterns look like, why they're important, and how it could help them and helps them stabilize some of their mental health problems could really be beneficial. All right, so lastly, we'll talk a little bit about depression, and then I'll talk about what can we do to have better sleep, right? So we know in major depressive disorder, patients with depression display very abnormal sleep schedules. They often report a hard time getting to sleep, insomnia or staying asleep, report multiple awakenings in major depressive disorder. Interestingly, sleep problems can often precede depressive diagnosis, And a study was done looking at people that were identifying as having sleep problems, and that predicted 47% of the new depression diagnoses in that group of problematic sleepers in the following year. And we know that patients that are in remission from depression or might be susceptible to depression, when they have sleep interruption, it often triggers one of those episodes. Again, looking at individual differences, if we look at a large group of major depressive patients, some of them have sleep problems, some of them have less sleep problems, and the ones with sleep problems have significantly worse outcomes, responses to treatment, and attrition rates in therapy. So again, strong interaction between good quality sleep and improving depression. There's also, unfortunately, a strong connection with sleep disturbances as a risk factor for suicide ideation, attempts, and death. And what we think happens is we have insomnia, we're not getting the restorative care, so the brain is not up to full speed the next day. There could be problems with nightmares, the sleep pressure is building up, and all of that is causing a lack of prefrontal control and an increase in emotion and emotional response, which underlies suicide ideation and attempts. And so, increased emotional responsiveness to stimuli, decreased rational decision-making are how we think this interacts. And unfortunately, adolescents appear particularly vulnerable to this link between sleep disorders and suicide. And that's probably because their prefrontal cortex is not fully developed. Your prefrontal cortex doesn't fully develop until you're about, it isn't fully strong and functional until about 21 years old. And so now we have a weaker prefrontal cortex in the adolescent brain, and we're not getting the sleep necessary to help strengthen that. And so this is why we think adolescents are particularly vulnerable to this connection. All right, so what can we do to improve our sleep patterns? So we have that circadian rhythm that's happening where during the day we have our highest body temperature, at night we have our lowest body temperature. That's one of the signals to our body to go to sleep and wake up. We also have this thing called melatonin that gets secreted a couple hours before we go to sleep, and right when we're waking up, the brain turns that off. So we think that's part of this 24-hour cycle. But one of the things that you should know about this 24-hour cycle is that when you wake up, stress levels are cortisol, our stress hormone, is released to help your body become alert and aroused and wake up. And when we wake up, we have our sharpest increase in blood pressure, And so I don't know how many of you, I know I've certainly been guilty of it, hit the snooze button on that alarm and roll back over and go back to sleep, and 5 minutes later get woken back up, and maybe you do that a couple of times. And the problem is every time you do that, you're initiating the sharp blood pressure rise. So if there are 250 work days in the year, right, and you hit the snooze button twice every day, that's 500 extra jolts to your cardiovascular system every year. And over a long period of time, a 30-year career, that really adds up to a strain on your cardiovascular system. And in fact, the highest prevalence of heart attacks happens usually on Monday morning when people are waking up for work after a weekend. And so one of the things we can do is to try and eliminate that snooze button and only have one sharp blood pressure rise in the morning to minimize that impact on our cardiovascular system. Another thing that people talk about are melatonin supplements, and this has become widely popular in the last 5 years or so, more so than it had been. And something that people really need to understand about melatonin and sleep is that the FDA does not regulate these companies. And you see here, I just picked a snapshot from Amazon. You see 5 milligram, 1 milligram, 10 milligram doses of this. Well, a study measured how much melatonin is actually in those over-the-counter doses, and 71% of them were off by more than 10% of what the bottle said it should contain. In fact, some contained as little as 80%, but even worse is some contained almost 500% more than what the suppliers were saying was in there. And surprisingly, they also identified about a quarter of those melatonin medications that contain serotonin that was not labeled as having serotonin in those. So have to be very careful of the quality of these nutritional supplements. Also, when doctors do prescribe melatonin, they tend to do it at a much lower dose than most people take over the counter. And there's no sort of regulation of that. Most people take 5 to 10 milligrams, where doctors are usually prescribing 0.5 milligram to 2 milligrams. The other thing that I'll say about melatonin is that there is a very strong placebo effect. So you are taking a pill before you go to bed, and this pill that I'm taking is going to make me sleepy. And guess what? You get sleepy. Now, is it because of the melatonin, or is it because you told yourself you're going to get sleepy? And there's not great evidence that when you take melatonin in your digestive system, of how much of that melatonin doesn't get broken down by your stomach acid and makes it into your blood supply. And then there's also very little evidence that melatonin as a chemical can cross from our peripheral body across the blood-brain barrier into our brain. So we really don't know, when you take that melatonin, how much of that is actually getting into the brain and having a brain effect. And it may be very little, but there's definitely a strong placebo. So what about prescription sleep aids like Ambien and Lunesta? These are called non-benzodiazepine types of drugs, which is because they bind to the inhibitory neurotransmitter GABA, and they have sedative properties, but not anti-anxiety properties. That's why they're called a non-benzodiazepine. Benzodiazepines are anti-anxiety drugs. They tend to have a 2 to 2.5 hour half-life, which is what you would want for an 8-hour period of sleep. But unfortunately, in older adults, that half-life can actually be 7 to 8 hours. Older adults have a harder time metabolizing these drugs, and so they have a much bigger effect on older adults. It's a strong memory suppressive. They're called hypnotic sedatives. So in addition to making you sleepy, they are strongly suppressing memory and memory formation. And these drugs, when they were created, were really designed for acute use, for short-term use, 7 to 10 days, no more than 10 days. And they were originally created for people that had some acute reason they couldn't sleep, some grief, some trauma event. And it was like, okay, if you take this drug in the start of this, it'll help you get through this period, but then we want you off of it after a week or 10 days. And unfortunately, these drugs are now being used much more chronically. And we know after about 2 weeks of use, people show withdrawal symptoms when they go off of these drugs. They have stomach and muscle cramps, vomiting, sweating, much like withdrawal from alcohol or nicotine. And a 2-year study looked at a large group of people taking sleep medications chronically and compared them to 2,000 controls not taking sleep meds. And what they found is in that 2 years, people on the sleep meds were 4 times more likely to die than the people not taking the sleep meds. And it's not that those sleep meds are necessarily are killing people, but it is disrupting our sleep patterns in a way that are causing more of those micro sleep events and not allowing our brain to be restored and at its full functioning level. All right, so kind of a last resort on that. The good news is that there are some really good techniques to improve our sleep quality. So as I mentioned at the very start of this, the number one thing is that it's non-negotiable, right? You can't let sleep be the thing that you bend when life gets tough. You need to plan your sleep schedule and really stick to it. Because consistent patterns are really what's important. I hope you've seen that you need that full 8 hours to get the slow wave sleep and the REM sleep that we need for our brain. You can't sleep 5 hours during the week and 12 hours on the weekend and make up for that. It doesn't work that way. All right, so what can you do? Well, one thing you can do is to set alarms, plural. So don't just set an alarm to wake up, set an alarm to go to bed. So if you've planned your sleep schedule and you say, I'm going to go to bed at 10 o'clock because I need 8 hours and I have to get up at 6 o'clock, then set an alarm for 9:45. And so, your phone goes off and you say, okay, I got to wrap up what I'm doing. I got to start my pre-sleep ritual and make it a reminder so that you don't overlook that. Your environment can matter. And so typically in cooler rooms, you're able to sleep a little bit sounder, but more importantly, reducing lighted sound, not having TVs on. If you need to wear an eye patch to keep light out, or ear plugs to help reduce sound if you can't control your environment. Those are things that can help you get that quality sleep. You don't want anything interrupting cycling in and out of slow wave and REM sleep cycles. And as I mentioned, it's good to have a pre-sleep ritual. Your body wants to know, hey, sleep is coming, right? And so one of the things you can do, often one of the reasons people have a hard time going to sleep is that they lay there in bed and they worry about things. They ruminate about things they didn't do, things they have to do tomorrow, and this interferes with their ability to get to sleep on time. So you can have a journal by your bed where if this starts happening, you sit up, you write down those things that you're worried about. It's also great to write 3 things you're grateful for, or 3 positive things that happened that day to sort of change your frame of mind. But then you can put that journal down, and when you lay back down, if you start to have those thoughts again, you can tell your brain, look, I wrote that down. You don't have to think about that right now. Get the sleep that you need, and tomorrow you can read about those things. They're right there waiting for you. You don't have to worry about them. And that can be very beneficial. Limiting bright lights 2 hours before bedtime, particularly blue light that comes from our devices, our cell phones or iPads. You can often computers and cell phones now have night modes where they switch to like a warmer temperature screen and don't have as much blue light. In fact, I just in the last 10 minutes watched my computer screen become more orangish because I have that set on my computer screen to reduce that blue light. You need to limit exercise, caffeine, and alcohol 4 hours before bedtime. All of those things interfere with our sleep. Caffeine, as I mentioned, is a adenosine blocker, but it's also a stimulant. Alcohol, sometimes we think makes us sleepy. And while it does cause us to be more sedated, it actually interferes with the brain waves during slow wave sleep and REM sleep. And so we don't get the quality sleep that you need if you've consumed alcohol. And lastly, sometimes, everything I've talked about are ways to mentally relax, right? But sometimes we need to physically relax our body. So doing some stretching, doing some deep breathing, maybe some meditation. There's some really good YouTube videos on how to physically relax your body before bedtime, some stretches that you can do that sort of take the tension out of our body and help our body be ready to go into that deep, comfortable sleep. So that's my time with you today. And I'm happy to take some questions now. I know that was a lot packed in an hour, but I do find this highly interesting, and I'd be happy to answer any kinds of questions.
Okay, so thank you so much, Dr. Pittman, and we're opening the floor for questions. We know that it is 6:34, and I appreciate everybody for hanging on during this hour. Are there any questions that you'd like to ask Dr. Pittman at this time? And you're welcome to put them in the chat or unmute or raise your hand or whatever feels like works for you. Go ahead. Fiola. Is she talking or she's just unmuted?
Okay, can you hear me?
Yes.
Yep.
Okay, my question is, what happens to the brain if I go to sleep? So I try to get to sleep by 8:30, and then at 1:30 I'm up, and then I fall asleep again after much stuff goes on in my brain. But I wake up and I'm feeling like I didn't get any sleep at all. So what is happening in the brain? And now I realize this is not something that I should be continuing.
Yeah.
What goes on in the brain?
So I will say that, the 8-hour sleep is general for human beings. And some people actually do function okay on less sleep. But in general, that's what we want to aim for. So what you're describing if 8:30 to 1:30 is about 5 hours, and so you're in that second half of the night where you're coming into a lot of REM sleep. And so something is probably just triggering you when you're not in that deep restorative sleep period to wake up. And so and then it might be harder to go back to sleep because your brain is more active at that point in time. So what I would say is one, if you find that you can't go to sleep or you wake up and you're awake, it's often good to get out of the bed and go do something briefly and then come back to the bed, because you want to make the bed the place where your body is asleep, not the place where you lay there and do other things, because then your body and brain associates that environment with things other than sleeping. So go get a glass of water. If you are having those thoughts, maybe that's the time that you use a journal to write them down and say, got it, I got those thoughts down. I don't have to think about them because they're right there waiting for me when I wake up. And maybe doing some of the physical relaxation, deep breaths, meditation, some of those techniques can help you get back into that slow wave sleep. So I'm not a sleep therapist. I know I've studied a lot about it, but that would be sort of my recommendation.
Okay, thanks. So going back to that, so if you have to write in a worry journal, wouldn't that require turning on the lights, which would then cause the brain to think that it's time to be waking up?
It could be. I mean, you do want to try and avoid bright lights, but maybe you have a little bedside lamp or something that you could do. If that's really the ruminating thoughts or what's keeping you awake and keeping you from going back to sleep, it's probably worth it to do that. And maybe you keep that journal in your bathroom and you walk in there and get a drink of water and turn the light and write that down, and then turn the light off and go back into your bedroom. So.
All right, thank you. One more question.
Sure.
What research has been conducted with pilots? Because I looked, I was watching a documentary and I see that their hours of when they're flying, they do have some long hours of working, and I know they probably get sleep in the plane as well. But
Right.
do you know of any research that they had where?
Yeah, I do know that career commercial pilots, they've looked at pilots that fly within one time zone, so they're short jumping between here in Miami and back sort of thing, versus transcontinental or ocean pilots that are crossing many time zones. That they have different health and memory outcomes, cognitive outcomes, where the pilots that fly longer routes consistently show greater risk for health complications and for cognitive problems. And that's, again, probably because of somewhat due to sleep disturbances, particularly when you're changing dramatically those time zones. So your circadian rhythm, that underlying ebb and flow, besides sleep pressure, is really governed by sunlight. Sunlight is what sort of resets that in the morning. And when you travel across multiple time zones, that gets out of whack, right? We call that jet lag, right? And so doing that consistently over many years definitely can have health consequences on pilots. And there is some research into that. I'm not as familiar. I do know of a study that looked at memory deficits and saw that flight crews on those transcontinental flights showed greater memory deficits than those that were within one or two time zones.
Okay, thank you. I really appreciate this presentation. It was quite informative.
Very good. I'm happy to be here and do it.
Truly, truly excellent presentation, Dr. Pittman. You've given us a lot of good and useful information that we can certainly apply. So hopefully everybody will apply the information that they've learned tonight and perhaps even take it on to other people that they know and educate them about how sleep may be affecting their lives, or sleep deprivation could affect their lives. We want to say thank you again to Dr. Pittman, and thank you to everybody who's been able to hold on and listen to the responses to the questions. And I have recorded this, and so I'll try to get it out. If you need a copy of the recording, do email me. Of course, you can find me at dhamelt@uvi.edu. And I will be glad to get you a copy of the recording. So thank you, everybody, and I hope you have a wonderful night and an excellent night's sleep. Bye-bye.
You too.